Okay, so it says draw the least squares regression line on the scatter plot above. Actually now, because I've had to move things, that's actually to the left. And so what we're going to do is we're going to take this equation here and we're going to plug in some values to find some spots, because they've done it again. They love to do this non-zero on the x. So we're going to put in those two endpoints, 52 and 60, and see what it spits out. So our equation is w equals minus 24.83 plus 1.739 times 52. That approximately equals 65.6 if you do a bit of rounding. So here's 65, that would be 66. Yes, so we're going to put a little mark just a bit below there. That should be fine. They're not going to be that fussy on the exam about this. And w equals minus 24.83 for our second spot, plus 1.739 times 60, and that equals about 79.5 roughly. So 79.5, that's just about there, because this is 80, that's 79, so it's going to be halfway between those two. We're going to come across the other side. Now I have gone to my locker and got myself a ruler, so we can do a lovely, beautiful straight line connecting those two up. Hopefully that looks good. There we go. Hopefully I've got my full mark there. Okay, this is remarkably similar to what we did before, but we've been given head length of 49, and we've got to round our answer to one decimal place. So we're just sticking numbers back into that equation again. So we've got w equals minus 24.83 plus 1.739 times, and they give us 49.0. And if we do put all that into the calculator, you get 60.381. We've got to round that to one decimal place. So we look here. This number doesn't mean anything. We just look over there. 8 means you go up 1. So this is going to equal 60.4 millimeters. Put your units. It's never going to kill you to put your units in there. So part C says, is the prediction of what we made above interpolation or extrapolation? If you look back at the graph, remember we were plotting between 52 and 60, remember? So we were plotting that line, and we had a 52 here, and then we had lots of little dots, and then a 60, and we drew our line. So 49 is below that, yes? So it is extrapolation, because outside the data range. Okay, I could say outside, you could say below, because specifically it's below. I mean, you can extrapolate down here, which is like 49, and it'd be above if you can extrapolate out this end as well. That'd be an above point, but in this case, the 49 was below. But if you just say outside the data range, you're fine for extrapolation. Okay, so it's talking about if we make a prediction with our line, that's what it's saying. The weight of a bird with a head length of 59.2 gives a residual value of 2.78. So it looks like we're going to have to use this equation again. They've given us a head length, so straight away we've got to work out that. So we know W equals, how many times have we written this out so far? 24.83 plus 1.739 times, they've given us a head length of 59.2, and if we put that into the calculator, it should spit out 78.118. All right, so that's the predicted value, and we got a residual, but the questions ask us to find the actual, so we got to look at what is the formula for that. So residual equals actual minus predicted. So we know 2.78, because that's our residual, equals the actual, which is what we're trying to work out, minus 78.118. Do a bit of algebra, just to remind yourselves, we've got to get rid of this minus 78.18, so we plus 78.118 to both sides, plus 78.118. Same thing both sides. So we just add up those numbers. This all disappears, and you end up with actual equals 80.8988. But again, check what the question's asking for. It says 1 decimal place. So we chop off here, and when then we look at that, this doesn't mean anything. So the 9 means the 8 goes up. So we've got to say it equals 80.9, and its weight. So we should really put a gram unit there just in case. Okay, so this is another classic problem that they always like to play around with, giving you R and wanting you get R squared, or give you R squared and wanting you to find R. So they've given us R is 0.5957, and we've got to use this information. What percentage of the variation of the weight in birds is not explained by the variation in head length? So first of all, do the maths. So R equals 0.5957. So we've got to square that. So R squared equals 0.5957 squared. And that gives you a long thing of 0.35485849. R squared is normally given as a percentage. So you've got to multiply that by 100 to get your percentage and give it to, as you can read, it's got to be to 1 decimal place. That's 35.5% because it says 1 decimal place. So that's 35.5%. But the full sentence for that, if you remember from doing this on the book, you would say in that thing, 35.5% of the variation in, now you choose the y in this, so this is weight, can be explained by the variation in, what is your x variable? It is the height, yes? The other, was that, well, what's left of 100%? 64.5% of variation can be explained by other causes or factors, whatever you want to say. Now, really, whenever you have these sentences, you just need to change this percentage, this is, and this percentage, because they're connected, they must add up to 100. This is whatever your y is, that's your y, and this guy, that's whatever your x is on your categories. But actually, this question was just asking for 1 mark. What was the 64.5% was all you actually had to answer. So as long as you had that, there, as long as you had that number, you would actually be happy. They would just have taken the number. But I just wanted to show the whole sentence structure, and that's definitely something you should have in your notes. So you just have to change the green bits for the percentages, and the blue bit is your whatever your y-axis is labeled at, which is your response, and the orange part is your x-axis, whatever the explanatory is. And it's just cut and paste sort of thinking. Okay, so we're looking at this residual plot. And what does it tell us about the association between head length and weight? Well, can you see any pattern in there? Is there anything that goes like this, or like this, or whatever? No. In that case, then we can say no pattern in the residual. In my lovely writing there. Therefore, the line is appropriate, or it might be a transform. If you did a log transform, you might say the log transform, but this case is no transform, so the line is appropriate. Therefore, there is a linear association. So we're always trying to do with this residual plot is to make sure that we end up with no pattern. If there's a pattern, then we've got to do a different transform. Okay, and that's all you're looking for. Definitely no pattern, lots of random stuff. So the line, using just a line to fit the data is perfectly okay.